This is Higher Free Chapter 1. In this chapter we're going to be going over sequences, specifically arithmetic sequences, Fibonacci sequences, geometric sequences and quadratic sequences. For in exercise 1.1 we're going to be going over very basic questions on how to use your calculator. And these questions do appear in the exams quite often, and how can we get full marks on these? So we're going to be looking at question 2. Now question 2 looks quite simple, that we just plug into our calculator and we get the answer. But these questions are usually 2 mark or 3 mark depending on how many steps are involved in each numerator or denominator. So the top is very simple. You just have the square root of a number take away another number. Now you plug what you have at the top into the calculator as it is, and we're going to get 2.792848,009. And when you work out what's in the denominator, 4.1 plus 6.7, that's 10.8. Plug this into the calculator as it is, and you get your answer, which is 0.2585970,378. Now part B is saying whatever we get for question A, we need to round it to 3 significant figures. Now the first significant figure is the first non-zero number, so ignoring the 0 that we have here, we start counting from the 2. 1, 2, 3. Now we round the 8 up as the number after it is 5 or more. So we're going to get 0.259. Exercise 1.2. Now this is on sequences in general. So here we need to find the rule, the next 2 terms and the 8th term. Now here we're doing plus 3 to get from 3 to 6. Then we do plus 3 again, and plus 3 again. Now remember, when it asks for the rule, it doesn't mean the nth term, it means what we're doing to get the next number. So in this case the rule is just plus 3. Now we need to work at the next 2 terms. If we're adding 3 each time, so 12 add 3 is going to give us 15, and add 3 again, 18. So question B is going to be 15 and 18. Now question C says work at the 8th term. Now here we have 1, 2, 3, 4, 5, 6. 6 terms. So let's add 3 again. We're going to get 21. Then we get 24. The 8th term is 24. Exercise 1.3 is an arithmetic sequence. An arithmetic sequence is a sequence where you add or take away by the same number each time. In this question they've given us a sequence. They've given us 5, 7, 9 and 11, and we have to work at the nth term. Now the nth term is a rule of the sequence. To find the nth term there are 2 methods, so we're going to cover both. So you have method 1, which is where you can use the formula. Now the formula is a plus d times n minus 1, where a is the first term and d is the difference. Now here from 5 to 7 we're doing plus 2, then 7 to 9 we're doing plus 2, then plus 2 again. So d would equal to 2, and a is the first term, which is 5. So a is going to equal to 5 and d is going to equal to 2. Now we're going to substitute these values into the formula, and we're going to have 5 plus 2 times n minus 1. Expand the brackets, we're going to get 5 plus 2n minus 2, then you have 2n minus plus 3, sorry. So that's method 1. Now method 2, so you have 5, 7, 9 and 11. Now remember, 5 is the first term, then you have the second term, third term, fourth term. So why is that important? Because we need to work the 0th term, so one number before the first term. So the first step is to find what we're going up in. So in this case, we're going up in 2. To find the 0th term, you're going to go back 2, so you're going to do minus 2. So the 0th term is going to be 3. The number that we go up in is going to be the coefficient of n. So you're going to have 2n, and the number that you have here is what you write here. So we have plus 3. If it was minus 7, you would write minus 7. If it was plus 9, you'd write plus 9. Question 3. The nth term of a sequence is 5n minus 7. Work out the first 4 terms. So if you're working at the first term, you have to substitute 1 into 5n minus 7. If you want to work at the 5th term, you substitute 5 into 5n minus 7. Because remember, this is the nth term, and we substitute the term number to work at the term. So if you want to work at the first term, we're going to do 5 times 1 minus 7. Second term, we're doing 5 times 2 minus 7. So you replace the n completely with the term number. Then 5 times 3 minus 7. Then 5 times 4 minus 7. That's going to give us 5 minus 7, 10 minus 7. So this is minus 2, 3, 15 minus 7 is 8, and 20 minus 7 is 13. So you have minus 2, 3, 8, and 13. Now the next question says, what is the difference between the 89th term and the 90th term? Now to find the difference between a term and the next term, look at the nth term. So we have 5n minus 7. The coefficient of n will always be the difference between a term and its previous or next term. So simply your answer here is 5. Now here question C, it says the last term of this sequence is 443. How many terms are there in this sequence? So what we're going to do, we need to work at the value of n. Remember, n is the term number. So that's going to tell us the number of terms in the sequence. So what we're going to do is 5n minus 7. And that's going to equal to 443. And we're going to work out the value of n. So we're going to do 5n equals to 443 plus 7, which is 450. N is going to equal to 90. So there are 90 terms in this sequence. Exercise 1.4. In this exercise, we're going to be covering geometric sequences. A geometric sequence is when you're multiplying by the same number each time. Now you could be multiplying by a whole number or a fraction, but you will be multiplying each time. So question 1 is asking us to check if it's a geometric sequence or not. Now to check if it's a geometric sequence, you have to divide a term by the previous term. Now when you check for a few numbers and you have the same number, then it's a geometric sequence. So question 1a. We're going to do 125 divided by 25. That gives us 5. Then we do 25 divided by the previous term, which is 5. Then we do 5 divided by 1, which is 5. So yes, it is a geometric sequence. So you write a little statement here. Question B. So we're going to do 64 divided by 36. So when you put this in your calculator, you're either going to get a fraction or a decimal number. This is going to equal to 16 over 9. Now when we do 36 divided by the previous term, that's going to be 9 over 4. Now these two fractions are not equivalent, So therefore this is not a geometric sequence. So it says if it is, write down the common ratio. Now over here, what we forgot to do was write down the common ratio. So the common ratio is what we call the number that we multiply by each time. So the common ratio is represented with R. So R is going to equal to 5. Now over here, it is not a geometric sequence. Question 4. Given the first term and the common ratio are 2 and 1 over 4 respectively, find the nth term of the geometric sequence and hence find the sixth term. So geometric sequences have a formula as well, and that is un equals to ar to the power of n minus 1. Now un just means nth term, and the a over here represents the first term. R represents the common ratio. Now in the first question we saw how we work at the common ratio. So if you're given a sequence, you divide a term by the previous term to find the common ratio. And here the first term is of course the first number in the sequence. In the question they've given us the first term. So a is going to equal to 2 and r is going to equal to 1 over 4. We're going to substitute these values back into the general formula given to us. So un is going to equal to a times a quarter to the power of n minus 1. Now if you want to find the first term of the sequence, you replace n with 1. If you want to work at the fourth term, you replace n with 4. So in the question here, they haven't asked us for the second term or the third term, only the sixth term. But for the sake of this example, we're going to go over the second term as well. So the second term would be worked out like this. So un. So what does that mean? You replace the n with 2. It means the second term. So you're going to have 2 times a quarter to the power of 2 minus 1. And that's going to equal to 2 times a quarter to the power of 1. Now anything to the power of 1, it doesn't change. So 2 times a quarter is going to give us a half. Now to finish off the question, we need to find the sixth term. So to find the sixth term, we're going to substitute 6 where n is. So we're going to have 2 times a quarter to the power of 6 minus 1. And that's going to equal to 2 times 1 over 4 to the power of 5. Now remember, this power is applied to whatever's inside the brackets. So this is going to be 2 times, so 1 to the power of 5 is just 1, and 4 to the power of 5 is 1024. So we're going to have 1 over 1024. Now 2 times 1 over 1024 is going to give us 1 over 512. And remember, these questions can all be done in a calculator. Exercise 1.5 is on quadratic sequences. A quadratic sequence is where you have a second difference. So from here we're going -2 to 7 to 12 to 43, then to 70. Now from -2 to 7 we do +9. Then from 7 to 22 we do +15. 22 to 43, 21. And 43 to 70, 27. Now none of the numbers here are the same. And even if I was to do 70 divided by 43 then 43 divided by 22, I would get different numbers. So clearly not a geometric sequence either. So it's a unique sequence where we have a second difference. And the second difference is the difference between the numbers that we're going up in right now. So we have 9, 15, 21, and 27. And the number that we're going up in is 6. So we're doing plus 6 here, plus 6 here, and plus 6 here. So we have a second difference. If there is a second difference, it is a quadratic sequence. Now the general equation of a quadratic sequence is an squared plus bn plus c. Now to find a, we need to halve the second difference. So that's the next step here. So we're going to do 6 divided by 2. We're going to get 3. And this number here is a coefficient of n squared. So this becomes 3n squared. Now over here we're going to make a little table to make it easier for ourselves. In the first row, we're going to write down the sequence that was given to us. So here you write down -2, 7, 22, 43, and 70. So this is where we write the sequence. Now we write down 3n squared. Now to work out the sequence for 3n squared, we need to substitute 1 into 3n squared to work out the first term, then 2, then 3, then 4, then 5. So when you substitute 1 into 3n squared, that's going to be like this. 3 times 1 squared. So you apply the square first. So always apply BIDMAS. So 1 squared is 1 times it by 3, 3. And then you have 3 times 2 squared. 2 squared is 4 times it by 3, 12. So we write these numbers in. 3, 12. Then you substitute 3 into 3n squared. So 3 squared is 9 times it by 3, 27. Then we get 48. And then we get 75. Now whatever you have in the original sequence, you take away what you get from 3n squared. So you do -2 take away 3. That's going to give us -5. 7 minus 12, -5, -5, -5, and -5. Now you can have two scenarios here. You can either have the same number repeating in the last row, or you could have a new sequence altogether. Now if you have the same number repeating, all you have to do is write down your 3n squared and write -5 at the end. And that is your answer. But if you had different numbers here, you would have to work at the nth term, because over here you're going to be getting a arithmetic sequence. You work at the nth term of that sequence, and then you put it at the end of 3n squared.